Welcome to section 4.4. We're going to be talking about finding the trig function for any angle and some techniques that we'll use to find those. So keep in mind our values for sine, cosine, and tangent. We still have SOH, CA, TOA remaining true. Little help, remember that phrase. Sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. So what they're saying is if we have our angle in standard position here, if we drop a vertical down and a horizontal, what it does is it creates a right triangle. This value right here is our x coordinate, and this value over here is our y coordinate, and the hypotenuse is the radius of the circle we could draw around. So all we have here is that y over r, the opposite over the hypotenuse, the adjacent over the hypotenuse, and then the opposite over the adjacent. And the cosecant, secant, and cotangent are just the reciprocals. So here we can use those values. So let's plot negative 3, 4, and that'll be the terminal side. So negative 3, 4, we're up here. So if we draw our triangle, this is the terminal side. So what it does, it creates a right triangle. Here's our radius. This length here is a negative 3. This length right here is a positive 4. And that's true because our x is a negative, our y is a positive. Now what we have to do is we have to find the hypotenuse of that triangle, the radius. So a squared plus b squared equals c squared. So 4 squared plus negative 3 squared equals r squared. So we get 16 plus 9 equals r squared, 25 equals r squared, r equals 5. And that's a positive. The hypotenuse is always going to be a positive value. So now what we can do is we can find the sine, cosine, and tangent. The sine of theta, and theta is right here. It's always going to be from that hypotenuse to the x-axis. So sine of theta, opposite over hypotenuse. So it's going to be 4 over 5. The cosine of theta, adjacent over hypotenuse, negative 3 over 5. And the tangent of theta, adjacent over opposite over adjacent, 4 over negative 3, which we'd write as negative 4/3. Always put that negative in the numerator. So really just all the things we've talked about before with geometry and so forth. Let's try another one. Negative 2, 3. So back 2, up 3. We're in that second quadrant again. Draw your triangle. Theta is down here at that spot. Here is our x coordinate, it's a negative 2, and our y coordinate is a 3. So we have to find the radius. So a squared plus b squared equals c squared. So it's going to be negative 2 squared plus 3 squared equals r squared. 4 plus 9 equals r squared. Take the square root of both sides. 13 equals r squared. Take the square root of the radius is the square root of 13. And now to find the sine of theta, that angle, opposite over hypotenuse. So it's going to be the opposite is 3 over the square root of 13. Unfortunately, we can't leave it like that. We have to rationalize it. Root 13 over root 13. So we get 3 square root of 13 over 13. Our cosine of theta, negative 2 over the square root of 13. Rationalize it again. You get negative 2 square root of 13 over 13. You're going to be rationalizing these in your sleep. And then the tangent of theta, opposite over adjacent, 3 over negative 2. We write that as a negative 3/2. Always move that negative up to the top. All right, so there's our sine, cosine, and tangent of any angle. Next, I talked a little bit about this in our tips and tricks video. What we're really thinking about here is in quadrant 1, our signs, positive for x, positive for y. In quadrant 2, negative for x, positive for y. In quadrant 3, negative for x and y. And in quadrant 4, positive for x, negative for y. That way we can think about what our values would be based on whatever the first quadrant is. Now, there's some other things that are true that we have to keep in mind. In quadrant 1, all of the trig ratios are positive. Sine is positive, cosine is positive, tangent, and their reciprocals. When I'm saying these, I'm including the reciprocals, cosecant, secant, and cotangent. Quadrant 2, the only one that's positive is going to be sine. Quadrant 3, the only one positive is going to be tangent, and in quadrant 4, the only one that's going to be positive is cosine. And a mnemonic to help you remember that, all students take calculus. It's not necessarily true that all students take calculus, but it helps me to remember in quadrant 1, they're all positive. In quadrant 2, sine is the only one that's positive. In quadrant 3, tangent's the only one that's positive. And in quadrant 4, cosine is the only one that's positive. Now we're going to use that right down here. Given that tangent is negative 4 over 5, and that cosine is greater than 0. So that's telling us that cosine is a positive and tangent's a negative. The only quadrant where cosine is the only one that's positive is in quadrant 4. So they're telling us to draw our triangle in quadrant 4. And that's what I'm going to do first. Here's my coordinate plane. So I know my triangle is in here in quadrant 4. Here's my theta. Tangent is opposite over adjacent. Opposite is 4, adjacent is 5. Now, it's a negative, and we have to think about which side would be negative. In quadrant 4, the x is positive and the y is negative. So the 4 down here, that's the negative. Now, we do need to find the hypotenuse. A squared plus b squared equals c squared. 5 squared plus negative 4 squared equals r squared. 25 plus 16 equals r squared. 41 equals r squared, so the radius is the square root of 41. Now that we got just from knowing what quadrant we're in and what our tangent was. So now we can find the sine of theta. And the sine of theta, still opposite over hypotenuse. So it's going to be negative 4 over the square root of 41. Rationalize it. Multiply by square root of 41 over the square root of 41. You get negative 4 square root of 41 over 41. There's our sine of theta. Our cosine of theta, adjacent over hypotenuse. So it's going to be 5 over the square root of 41. Rationalize. 5 square root of 41 over 41 is our cosine of theta. So you're looking for a couple of things. You're looking to see what quadrant we're in, and then draw your triangle and label the values correctly, including the signs. Number 4, sine is positive, and now tangent is less than 0, so our tangent is negative. The only quadrant where the sine is positive and the tangent is negative is quadrant 2. So when I draw my triangle, I'm drawing my triangle in quadrant 2. In quadrant 2, our triangle looks like this. Theta is going to be down here at the bottom. Here's my right triangle. Sine is opposite over hypotenuse. So opposite 4, hypotenuse of 5. We need to find the missing leg. A squared plus b squared equals c squared. Pythagorean theorem. 4 squared plus b squared equals 5 squared. 16 plus b squared equals 25. Subtract 16. B squared equals 9. So that means that b equals 3. Now, be careful. We're in quadrant 2. In quadrant 2, x is negative. So that leg at the bottom isn't just a 3, it's a negative 3. So make sure you fix the sign there. So now we can find the cosine. And the cosine of theta, adjacent over hypotenuse, is a negative 3/5. The cosecant of theta, that's the reciprocal of sine. We didn't even need the triangle. The reciprocal of 4/5 is 5/4. That's the hypotenuse over the opposite. Now we're going to look at the 4 quadrant angles. Now remember our quadrant angles. Here's 0, pi over 2, pi, and 3 pi over 2. So these values here, we're going to 1, 0, 0, 1, negative 1, 0, and 0, negative 1. That's going to help us find the sine, cosine, and tangent. So for the sine of 0, it's the x, it's 0. The cosine of 0 is the y, which is 1. And the tangent, divide, it's going to be 0. The sine of pi over 2. Now we're here at pi over 2, so our sine is 1. Our cosine of pi over 2 is 0, and now our tangent, whenever we're on that y-axis, it's going to be undefined. For pi, the sine of pi. Now we're over here at negative 1, 0, so the sine of pi is 0. The cosine of pi is now negative 1, and the tangent of pi, when we divide sine by cosine, it's 0. And now the sine of 3 pi over 2. We're at 3 pi over 2, we're down here. So the sine is the y, it's negative 1. The cosine of 3 pi over 2 is our x, that's 0. And our tangent of 3 pi over 2, you can divide, or you can see that we're on that y-axis. It's undefined. Very good. We're going to be talking about reference angles in the next section and how we can use those to help us evaluate. And I will see you in the next part. Thank you.